Hello everyone, welcome to week 3 of Building Server Systems. I hope you are enjoying the course so far. This week we'll continue our focus on energy. And we'll introduce the concept of building science, which is, the course is really all about building science because building science is about the operation of different systems within a building, which obviously is the purpose of the course. So the whole thing is building science. But we'll really hone in on heat and heat flow. And the relationship between heat and temperature, which may not be as obvious as you think, but then get into the basic heat transfer mechanisms, your conduction, convection, radiation. This should be a review for you, but it's important that you understand the different ways that heat flows in and out of a building, because that heat flow is an essential consideration in HVAC and building comfort and so forth. So we'll look at heat flows. Basic temperature aspects of different temperatures and different temperature scales, and their significance. Really important aspect here is the U value and R value. Those U value we use all the time to calculate the heat loss through a surface like a wall or a roof or insulation or whatever. And so U value is a really important consideration. And we'll look at the relationship between U value and R value and different types of insulation and how that impacts heat flow. Also, we'll look at the basics of heating degree days, which is just a way to indicate the climate. Basically, the heating degree days, the simple way to think about it is more heating degree days means it's a colder climate and you need more heating, all else being equal. And so that's another one of those considerations that we can use to help calculate our heat loss. In this case, the annual heat loss through a surface. Okay, so HDD is very important in terms of calculating the heat flow. We'll go over the basics of different types of insulation. You have, your sort of like fiberglass bat, and your foam board, spray foam, all that stuff. So you look at some different types of insulation here as well. Just so you have a sense of how homes are insulated or buildings are insulated. And we end on efficiency calculations. So this is very important to understand. There's a really basic formula. It's efficiency equals output over input. And then, of course, with some basic algebra, you can derive these other two formulas. So the point is, when you're doing an efficiency calculation, as long as you have any two of the variables, you can get the third, because you have all the equations for efficiency, output, and input. So this becomes really important when you are calculating how much you're actually paying for energy, and here's why. Heat. So we'll take right now as an example. It's cold outside. It's winter time as I record this, and so it's warmer inside my house than it is outside, right? It's probably like 40 degrees outside. It's 70 degrees or so inside. And so the heat naturally travels through the walls. You actually can't stop it. Like, you can slow it down using insulation and so forth, but heat is always going to go from warmer to colder. So the heat, the wall behind me is an exterior wall. Heat is flowing through that wall, and you can sort of probably see that window peeking through the curtain. It's flowing much more rapidly through that window because it has a lower R value, and that's a U value. And so that's where this all ties together, is you have heat that flows through a surface, and that, decreasing the U value or increasing the R value will actually slow down that heat, but it's still going to travel through all these surfaces. So now I have all these surfaces all over the house, right? So I have walls and a roof and basement and so forth. So there's heat flowing through there. So you lose heat from inside to outside, and then you have to replace it in order to make, to continue to keep it at around 70 degrees. So in my case, I actually have a natural gas furnace that's relatively high efficiency. Well, the problem is that it's impossible to have a 100% efficient furnace. So you always lose energy when you convert it from one form to another, and that's the second law of thermodynamics. And so if you can, and you'll do some of this, you'll do a part of this for your lab this week, but you can calculate the heat loss through all of the various surfaces in a building over the course of a year, and then you figure out, okay, how much energy did I lose, and then you need to replace it, in this case with the furnace, and by using your efficiency calculations, you can figure out, okay, So I lose this much, and because my furnace is less than 100% efficient, I have to add this much energy back through my furnace. And so it's always going to be, you're going to have to add more than you've lost because the furnace is less than 100% efficient. So that's where one way that these efficiency calculations come in handy. And there's some other applications for it as well. Okay, so that's the focus of this week really is to do that, like figure out, understand how heat flows from warmer areas to colder areas, and then you'll learn how to calculate, like based on the insulating value of those surfaces, how much heat is lost, how rapidly it's lost, and how you can apply that. Okay, so that's really the focus of this week. Again, it's a very practical lesson for sizing furnaces and understanding how much you're going to have to pay for energy. But I hope you enjoy the content this week, and if you have any questions, shoot me an email.